let's define acceleration as rate of change of velocity. We define it as rate of change of velocity per unit time. Okay. So as we know that velocity is a quantity, it's a vector quantity, and it has magnitude as well as direction. So here, how do we find a change of velocity? Let's see. It's a little bit different from our earlier definitions, earlier whatever we had done. Earlier in class 9, we were mainly dealing with, we said acceleration is equal to v minus u over t. Okay. So here we had found out the acceleration, and we generally consider the magnitude, because over there we had an assumption that the objects are moving in a straight line. So when the objects are moving in a straight line, you can directly use this without bothering about the direction. Now, suppose an object moving in a circle, and let us try to find out the acceleration over there. So over there, we also need to consider about the change of directions. Okay. So for example, just as an example, we consider how to find out the change of velocity or acceleration during circular motion. Okay, so consider here an object moving in a circle. So let us have different instances of the object. So this is, I am marking the different instances of the object, and we'll try to find out the change of velocity, and we'll see in what direction does the change of velocity occur. Okay. So here, if we observe these 2 points only, so here the velocity is tangential. Here also the velocity is tangential. So these are 2 points where we find that the velocity, and let this object move moving in the anti-clockwise direction in the circular path. So this is what you have, the initial velocity u, and this is your final velocity. So here we have made certain assumptions. Our first assumption that we put here is that it's moving with a uniform speed. We consider here an object moves in a circle an object moves in a circle with uniform speed. So here only the directions are changing. The magnitude of the velocity, it remains the same. So can we call it as an accelerated motion? Yes, can we put it, and can we call it as a uniform circular motion, or can we call it as an accelerated motion? Because we find here that the magnitude of the velocity is not changing, but its direction is changing. And we know that velocity is magnitude and direction. So since velocity is only, only, नहीं कोई नहीं किया. Okay. So we find here that there is no change of speed, but there is a change of that velocity. There is a change of direction. So how do we find here acceleration? So we have to find out v minus u. Let us see, going step by step, we need to find out v minus u. How do we find our v minus u? So our v is directed towards this direction and we have u. So v minus u can be written as, we can write it as v plus minus of u. And using the laws of vector addition, we can evaluate the amount of acceleration. We can find out the acceleration. So if we solve our vectors, if we use our vectors over here, so see, this will be your direction of velocity, and in the upside here you have the direction of speed. This is the initial velocity. So you have both initial and final velocities. Final velocity v, this is initial velocity u, both have the same magnitude. Now if you have to take minus u, u will be a vector of same magnitude but in opposite direction. So we'll be putting here minus u. Okay. So this will be our minus u. And now using the parallelogram law of vector addition, we can find out the magnitude of velocity. We can find out the magnitude of acceleration. So this is our minus u. And now we can find out v plus minus u. So as per the parallelogram law of vector addition, we must complete the triangle. So we must complete the parallelogram, as these two vectors, they are co-initial vectors. So we should complete the parallelogram. So let's complete the parallelogram here. So this is our parallelogram. The opposite two sides are here. Let's put up the parallelogram. So as you can see, the diagonal of this parallelogram will be the resultant. So this diagonal of the parallelogram would represent v plus minus u, and this, if I divide this by t, so I will get my acceleration. Okay. So from this, the direction of acceleration is clear. Can you find out what will be the direction of acceleration? So here we find out at every point that the direction of acceleration, it is directed towards the center of the circle. You observe the same thing at this point, and you see the direction. So this direction is pointing towards the center of the circle. You can observe by taking this arrow. Let's say if I take this arrow here, just over here as the resultant. So see, it is pointing towards the center of the circle. So our acceleration at every point, at whatever point you find out the acceleration is directed towards the center of the circle. So you will have your acceleration directed towards center. Got it? So in this way, we can find out the amount of acceleration. So v plus minus u can be obtained using the resultant law, using the formula of parallelogram law, where the resultant was obtained as under root of a squared plus b squared plus 2ab cos theta. So in this way, we can obtain the value of acceleration. Got it? Is this clear to us?
Yes, sir.
Yes. So this way we can move towards acceleration. So now we can find out acceleration in any circumstances, that even if the speed is constant, it's moving with a uniform speed. So we found out that there is acceleration, and that acceleration is always directed towards the center of the circle. So here we find out that acceleration is directed towards the center of the circle. So this acceleration will every time it will point towards the center of the circle. Now, uh, is this acceleration a uniform acceleration or a non-uniform acceleration? Yes. Is this acceleration uniform or non-uniform?
Sir,
Yes.
a uniform.
Okay. See, as I told you that every time the acceleration is pointing towards the center. So of course the magnitude of acceleration is same everywhere, but the direction of acceleration is changing. Okay. So since the direction of acceleration is changing, we will say that acceleration is changing. Acceleration is also not constant here. Here we have acceleration is also changing since the direction of acceleration is changing at every point. At every point it is pointing towards the center. Still, the amount of acceleration or the direction of acceleration is changing. Okay. So a uniform circular motion is a motion. If you have a uniform circular motion, so here we have acceleration. It is an accelerated motion, and this accelerated motion is not a uniform acceleration. This is a non-uniform acceleration. So we have here a non-uniform acceleration, right? Yes. So this is non-uniform acceleration. Understood?
Yes, sir.
Yeah. So here we have non-uniform acceleration. That means, of course, in class 11th, we are going to go into much depth with scalars and vectors. Now, with just relating to the vectors, I will give you a small question. Okay. This is non-uniform acceleration. Now, let's see. Uh, let's see here. Two forces. Two Newton and 3 Newton act perpendicular to each other. Each other on a mass of on a mass of 50 grams. Find the acceleration. So find this acceleration. Then I'm giving another question here. So find the acceleration, and also just let's elaborate this question a little bit. I think it will be okay. First, you find the resultant force, and the resultant acceleration. So you have to find the resultant force and resultant acceleration. Got it? So can you do this question? We just have to use the direct formula of addition of forces.
Yes, sir, I'll try.
Now, So you can use the formula here. So you have two forces acting at 90 degrees to each other. F equals the resultant F we are finding. This would be equal to the under root of F1 square plus F2 square plus 2 F1 F2 cos theta. So the angle, since they are acting perpendicular to each other, so we are given the angle between them to be 90 degree. We put here the value of theta as 90 degree, and we know the value of F1 and F2. So here we know F1 equals to 2 Newton, F2 equals to 3 Newton, and theta equals to 90. So if you get F equals under root of F1, which is 2 squared, plus F2, which is 3 squared, plus 2 times of F1, F2. So 2 multiply 3, multiply cos 90. So as we know, cos 90 is 0. So this whole term will vanish. And you will have under root of 4 plus 9. That's root 13. So your resultant force would be root 13 units. And we can find the direction of this. So the direction of this force can be calculated. The direction of the resultant can be calculated by drawing the diagram. So here you have the two forces, F1 and F2 acting perpendicular to each other. F1, F2 acting perpendicular to each other. And the resultant would be represented by the diagonal. You can say that this would be the resultant, which will be represented by the diagonal. So this is your under root 13 we have got, that this is under root 13. Now we want to find out the direction in which this force is acting. So this force is acting in a direction theta, and to find out this theta, we must find out so we shall find out here. This is your F1. So tan theta can be obtained as F1 by F2. So F1 is 2, you find 2 over 3. And hence you find theta equals tan inverse of 2 by 3. So currently I am using calculator. You can also use a trigonometric table. So you can use a trigonometric table for it, and hence you can complete. Currently, if I use my calculator here, so I can use like this. We have tan inverse of 2 by 3. So I'm just 2 by 3. So tan inverse 2 by 3, this is in radian. I want in degree. So your answer is 21.14. Okay, still some incorrect is there. Okay. So that is 2 by 21.14 degree. That's the answer. Got it? So I know the direction. I have calculated the force, and hence I can also find out the acceleration. If I know the value of force, I can find out the value of acceleration. So for that, I use a calculator here. I show under root 13 to find under root 13. That's 3.6. So our force here is 3.6 Newton. Its direction is also given. So theta we obtained as 21.14 degree. And now we can find out acceleration. So acceleration will be given by force by mass. Force is 3.6 divided by mass in kilogram. So that is 50 multiplied 10 to the power minus 3. That will be kilogram. So you can convert it, obtain the answer, and get the value of acceleration. So I hope you have understood. Shall I give you one more question? Yes. Just one. Just one. Are you there? Just one. Just one. Okay. Were you there?
Sir, can you hear me?
Yes.
Sir,
So I can give you one more question. You shall just try to find out the amount of acceleration in the same. So here, coming to the previous slide, here we had studied about the acceleration acting towards the center. So this very acceleration which act towards the center is called as centripetal acceleration. So this is our centripetal acceleration. Okay. Okay, just one. Thank you. I'll be sharing just a few questions. You can try to attempt those questions. Bye, just one.